A research group using hospital records developed an approximate mathematical model relating systolic blood pressure and age as this formula. So let's where it says that P of x is actually pressure and x is the age. Okay, so if that is the case, we have the relationship between the blood pressure and the age given by this formula, right? So it's impressive that they are able to figure out the mathematical model relating with the systolic blood pressure and age. Okay, no problem, but this is just the information we have given. We have some formula given, right, which is a relationship between the blood pressure and the age. But what is the question here? The question begins here. What is the rate of change of the pressure? So that's what you need to figure out. You need to figure out what is the rate of the change of the pressure at the end of 20 years. So you need to figure out the rate of change of the pressure at the end of the 20 years. That is the main question. So how do you find that? We know that in calculus we try to find out the rate of change of the function by using the derivative, right? So we need to find the derivative. So it looks like then our goal is to find the derivative of the pressure at 20. Okay, that's nice. So we just extract the we extract the information. So if that is the case, let's try to write down the given thing. Okay, so we have here given P of x, the relationship between the systolic blood pressure and the age, as P of x is equal to 60 plus 25 times ln of x plus 1, right? And our goal is to find the derivative of this function with respect to x, right? But then we need to evaluate that at 20. So we need to figure out what is P prime of 20. This is our main question. So we have given the relationship between the systolic blood pressure and the age by this formula, and our goal is to find what is P prime of 20. So how do we find this? So you might have noticed, if we need to find the P prime of 20, right? So if we need to find the P prime of 20, before this we actually need to find what is P prime of x. So let's try to find the derivative of this. Do you know how to find it? Alright, I'm going to write down the derivative of the P with respect to x. If you want to know more details about how did we find the derivative of the P of x, please watch the video. Okay, there is a video available over here, so please watch that. Alright, so what is the derivative of the P? What do you get it? Do you get 25 over? Do you get 25 over? Let's say, now there is no question mark, we are solving it, right? So 25 over x plus 1. Okay, so this is the derivative. So we have the P prime of x. Okay, so to evaluate the P prime of 20, then what we just need to do is, because this is our main question, right, our goal is to find P prime of 20. So if that is the case, to find that, what can we do now? We can just evaluate this P prime of x at 20. That can be done by wherever there is x in P prime of x, we can replace by 20. So if that is the case, 25 over 20 plus 1, and which is actually 25 over 21, and that is the rate of change, right, of the pressure at the end of 20 years, which is approximately, if you want to write down, this will be 1.19, and this will be in millimeter per year, right? So that's the unit we have given, so millimeter per year. All right, so if the question was what is the rate of change of the pressure, right, at the end of the 30 years or something like that, then what do you need to do? You just need to evaluate what is P prime of 30, right? So that's how we can do. But on this end, this is the same way how we have evaluated P prime of 20, we can do it. The only thing here we need to know is how to find the derivative, right? And we need to understand that on this application, rate of change is the derivative. This is the main thing here. If we didn't know that finding the rate of change, to find the rate of change, we need to use the derivative, we cannot do anything at all, right? So this is the main thing you need to focus on. And once you figure that out, we need to find the derivative, which, like I said earlier, you can still watch the video where we have find the derivative of 60 plus 25 times ln of x plus 1. Okay, and or once you know the derivative, then we can just evaluate that at 20. All right, so this is the required answer. I will just challenge you to try to figure out what is p prime of 30. All right.